Dear students, now we will see what do we mean by N-type semiconductor. Now, yesterday we saw that there are two important intrinsic semiconductors which are called as silicon and germanium. So you can take either silicon or germanium and make them extrinsic. That is, you can add some impurity to it. Okay. Now we saw that if you add impurity to a pure semiconductor, its conductivity will increase, and that is why we have to add certain impurity. Okay. Now this can be of two types. You can have pentavalent impurity, you can have trivalent impurity. If you add a pentavalent impurity to a pure semiconductor, then you are going to get a N-type semiconductor. Now what does this mean? This means that if you are having your silicon atom or germanium atom, so in this case we have taken silicon atom. So this is a silicon atom, this is a silicon atom, this is a silicon atom, this is a silicon atom. Now these silicon atoms will be having 4 valence electrons because it is tetravalent. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. And a small amount of pentavalent impurity, that is element which are having 5 valence electrons like arsenic, will be added to this silicon. So this one arsenic atom is shown over here. Now this arsenic atom will have 5 valence electrons. Out of that 5 valence electrons, 4 will make covalent bonds. 1, 2, 3, 4. This one will make a covalent bond here. 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 And the 5th electron will become free. The 5th electron does not have any electron to make a covalent bond because silicon, whatever is there, the main element is a tetravalent element, and you are going to add a pentavalent impurity. So these 4 electrons of arsenic, a pentavalent, will make bonds with the 4 shared valence electrons of silicon, and in that process 1 electron will come out as free. That means if you add a small amount of impurity of arsenic, that is pentavalent impurity, to a pure semiconductor like silicon or germanium, then you will get many such free electrons. And these free electrons will help you to make the current flow. They can be called as conduction charge carriers. So here you can have an energy band diagram where you can show this a conduction band full of free electrons. So there are many free electrons. Okay. So there are many free electrons means what? There are many majority charge carriers which are called as electrons in N-type semiconductor. That means N-type semiconductor has majority charge carriers as electrons. Why we are calling them as majority charge carriers? Because due to temperature increase also, there will be some covalent bonds breaking. Not because of adding impurity. Because of temperature increase also, some covalent bonds can break and a few electrons and holes can be generated. In that case, holes which are there will remain in the valence band, and those holes will be less in number. And in that case, you can call those holes as minority charge carriers. So for a N-type semiconductor, electrons are majority charge carriers, and a small amount of holes also will be there because of increase in temperature, and those holes are called as minority charge carriers.